Hi everyone, just a quick video to talk to you about linear systems. This is something that you covered last year in Ag 2. Recording this on a beautiful Sunday afternoon at about 1:30. Hopefully none of you are stuck inside right now and that you're all outside enjoying the weather, as I will be soon. So anyway, linear systems. Let's talk about what they are, and then I want to give you an example of consistent linear systems and inconsistent linear systems. Essentially what a linear system is it's two or more equations that may or may not have a common solution. So let's put that definition down. So two or more equations, and you can think functions also. So two or more equations that may or may not have a common solution. Okay, so what are we talking about? First of all, we're talking about a common solution. So if I were to give you a system of linear equations, you don't have to write this down, this is just for an example. Let's say I say 3x plus 4y equals 7 and 2x plus 7y equals 10. What we're looking for are an x-coordinate and a y-coordinate that I plug into this equation and I get an answer of 7, and I take that same x and y coordinate and I plug it into that second equation and I get an answer of 10. Okay, that's what we mean by a common solution. So sometimes linear systems have a common solution, sometimes they don't. I'm not sure which one this is, but I just wanted to give that to you as an example. Okay, so that's what a linear system is. Last year you looked at 3 different ways to solve them. You graphed them and figured out where they crossed, and that was the common solution. You did it by substitution, and then you also did it by elimination. For this class, we're going to focus primarily on elimination for right now. Okay? So we have linear systems, your basic definition. We have some subcategories of linear systems. The first one is what we call a consistent linear system, and that's a system that has at least one solution. So a system that has at least one solution. Now, make a note of it, that it may have more than one solution. And I want to show you 2 examples of what's considered to be a consistent linear system. Alright, so I'm going to go over to Desmos. Whoops, ignore that. So let me put these first 2 up here, because these 2 are a linear system. Okay? Well, let me set that back up. So you can see I've got, this one is negative 3x plus 7. This one is negative 2x minus 9. You can see they're going at different slopes, and that they're kind of angling towards each other. Okay? You can see where they cross. They cross right here. What's that coordinate? At negative 1641. Excuse me, 16 negative 41. Okay, that's the common solution. So if I were to plug 16 into this function right here, I would get an answer of negative 41, because 16 times negative 3 is negative 48 plus 7, negative 41. At the same time, if I were to plug 16 into this equation, I would also get an answer of negative 41. So if I plug in 16 in there, I get 16 times negative 2, which is negative 32, minus 9 is negative 41. So this is our common solution. These 2 equations, this system of these 2 equations are considered to be consistent. Okay, so that's what we're talking about with a consistent system. They have one or more solution. Right, that's what you dealt with a lot last year in your math class, was finding this point right here, this coordinate, where they intersect, what the common solution is. There's another type of consistent system, and watch this. So I'm going to graph number 3 and number 4, call them a system. So look at what, so there's x plus y equals 4. You get that graph right there. And then watch this one right here. Notice it's right on top of it, okay? And if you look at these two equations, they're kind of the same. It's just this one down here, everything's multiplied by 2. This is consistent also. These 2 equations make a consistent system. Because notice the definition was a system that has at least one solution. This one right here has what we say many solutions. Why? They're basically the same thing. So any x and y I plug in here will work in here also. I could go 2 and 2. That would work. 3 and 1, 5 and -1. They would work in both of them. So that's a second example that we sometimes don't look at as much of a consistent solution or a consistent linear system, if we want to use the same terminology. So those are the two types, where you have one solution and then where you have many solutions. Okay. As we move out of linear systems, we may get more than one solution, but just for linear systems, there's those two options. There's also this thing called an inconsistent linear system, and that's a linear system that has no solution. So a system that has no solution. Okay, let's take a look at an example of that, which will be these last two. Okay, notice I graphed that one, and then notice I graphed the second one. What do you notice about them? They're parallel, right? What do you notice about their equations? Hopefully you can see right here they have the same slope. Okay? Anytime you have two equations in a linear system that have the same slope, you're going to have what's called an inconsistent system. Why? Because they're parallel, and so therefore they're never going to cross each other. I think we can understand the fact that these two lines will never cross each other. Okay? So that's what we call an inconsistent system. Has no solution, and let's write a couple of other things. Let's say the lines are parallel. And what do we also know about parallel lines? Same slope in our slope-intercept, y equals mx plus b. So our same slope. Okay, so that's the idea of what a linear system is, what a consistent linear system is, and what an inconsistent linear system is. So what we want you to move on right now is to this right here. That's the next thing on your agenda. What I would do is I would take each of these and rewrite them in slope-intercept form like you did in your warm-up. And then you should be able to answer whether they're consistent or inconsistent. And each of these graphs